Hello, everybody. Sorry for my scary French accent. I'm French. First of all, thank you, Jerry, for providing us the opportunity to be here every year to meet all of you, the men of the art of Vita and SOSA, and also editors, of course, some of our partners and competitors. I am Pierre Ansquer. I work for Interface Concept in France, a company which since almost 40 years imagine, specify, design, manufacture and sold boards for the embedded business. I'm in charge of the pre-sale support at Interface Concept, and my presentation today is a kind of summary between evolution of Ethernet protocols and the Vita 65 recommendation. Interface Concept is well known for its range of Ethernet switch. As a lot of people here, our business is to contribute our part in the design of embedded system. That means selection of payload board, CPU, FPGA, GPGPU, I/O switch. Sorry, Scott, I missed power supply in my slide. It's a mistake because, of course, power supply is a key element of such a system. Then architects have to select backplane, existing backplane, or more frequently to adapt backplane to address the function targeted, integrate this in a chassis, and then select a cooling scheme depending on the constraint of the system, which could be constrained mainly driven by the carrier. Here it's a French fighter. It could be it could be a boat. It could be shelter and so on, and then the solution could be air-cooled, conduction-cooled, airflow through, and even liquid flow through if needed. In such a system, in fact, the problem is to make the board interworking, exchanging data. This exchange can be named data flow, control flow, depending on the throughput expected. It can be based on old legacy buses, such as VME, or more point-to-point protocol, which can then interconnect by point-to-point connection, which can help to build daisy chain, full mesh topology, and of course, when the selected protocol allows this, can require the use of a switch. I talk about VME. Of course, the rest of the presentation is based on OpenVPX and especially SRIO OpenVPX. But VME still exists. We are still building VME boards, as I suppose a lot of you, with the new technology, either switch and CPU. For legacy program, which claim for still claiming for VME solution. Concerning VME, the history of the history before this last decade, and all other technologies that I will just tangent during my presentation. Of course, I strongly invite you to come back to the presentation of Greg Rocco, which is just an amazing collection of information, a mine of information, and a Bible of all the technology used in our system. Thank you, Greg, for this presentation. As I said, so when authorized and when the protocol accepts this, a switch can be used to interconnect all the board without claiming for several ports on each endpoint. Here is an example of a backplane we imagine and define with our partner in US, Elma, where we had two parts, one dedicated for communication with CPU and FPGA and I/O boards through expansion plane. On the other side, processing part of the system, both interconnect through a dual plane switch. Of course, this claim for it's just on the story of plumbing, which has been addressed by Vita 65 to organize this above the Vita 46 and define slot profile and backplane profile to authorize interconnection. So pipes have been defined, ultra-thin pipe, thin pipe, fat pipe, dual fat pipe, and so on. And following this recommendation, you can assume a correct interconnection of all the elements in your system. Obviously, it's not enough. You have defined the pipe, but of course, you have to take care about the capability of both ends to discuss. You don't have to place to fill the pipe with water if oil is expected on the other hand. So the Vita 65 and Vita 65.0 and Vita 65.1 has defined a set of module profile which define for each pipes exactly which type of protocol is accepted. In the present case, in fact, we have a switch and a CPU interface through a backplane, a fat pipe data plane, and ultra-thin pipe control plane. You can see in the module profiles that both are using 4 gig Ethernet protocol on a fat pipe for the data plane and 10 gig Ethernet protocol on ultra-thin pipe for the control plane, and it works fine. This drives to this beautiful colored slide with all the Vita 65 slot profile, with or without optical and coax connectors, or place for coax connectors. One word on SOSA. SOSA has pointed out maybe a lack of some of the profile defined by 65.1 protocol, where a lot of pins stayed user-defined, and this had the problem. As a consequence, in fact, it could limit interoperability. So everybody knows that SOSA arrived to define an ecosystem, a subset of new profile which fully define exactly all the pin of the slot profile, and as a consequence also different kind of module profile for the use of this slot profile. Both Vita 61 plus SOSA profile are merged in this on this slide. Ethernet now, I summarize here the standard architecture of an Ethernet switch. You can see that an Ethernet switch is mainly based on an Ethernet matrix, highly integrated packet processor, which interface the Ethernet port of the system, which provides a physical interface, MAC interface, layer 2, layer 3 protocols, and which is interfaced here in the present case through a PCI Express link. It could be an Ethernet link or something else, with a management unit, processor supporting a software which controlled, configured, and also implement some layer 3, layer 4 functions. On the other side, the SERDES can be directly connected to the backplane for protocol which allow this electrical interface, such as base KX, the base 10 giga KR, and 10 giga, 40 giga KR4. When legacy interfaces are claimed, such as historical 1000 base T and 10 giga base T interface, you can have a physical transceiver and transformer. This is a split architecture, of course, depending on the selected matrix. You could include some of nearly all of these features in a unique components. It could be also an FPGA, as already said before. I just missed the optical port, which could be added. This is an example for switch slot 3, 10U 71G slot profile. Of course, it has been said several times since the beginning of the day, the last 10 years offer you an incredible technology development, PCB material, foundry process technology, of course connectors, thanks to Samtec and others. This plus new tools, signal analysis, thermal simulation, drive to today an ecosystem of amazing performance for both processing and data exchange. As an example here, you can see in 2010 on the right at the bottom, in 2010 we had IC components of 37 millimeters per 37 millimeters, offering 24 giga Ethernet ports. Today, in 29 per 29, you can reach 32, 25, and 50 gig Ethernet port, and at the top, in something which just a little bit larger, you can have 72, 25 gig ports in a unique IC components, including not only the Ethernet matrix, but also the management processing. So it's incredible. Ethernet roadmap, if you are interested in, I invite you to visit the Ethernet Alliance website, where you have the roadmap, this one, but also the previous one. It's still interesting. And you can see that in 1980, we were talking at 10 megabit per second, 1990, 100 megabit, beginning of the century, 10 gigabit. And now we are talking about 200 gigabit and even 400 gigabit. In yellow, you can see terabit, which appears. This is, of course, due to, for the same reason, with all the technology, of course, fatter pipes, because Ethernet protocol also evolved to integrate fatter pipes, and signaling method. In the past, all was based on NRZ solution. Today, PAM4 signaling method allows to double the throughput on a single lane, so it's impressive, and coherent signaling method will also optimize the throughput in the future. As a consequence for Vita 65, in fact, it's that in 2010, 2012, we only had a poor list of 6 Ethernet protocols with a maximum of 10 giga on 4 lanes, and today we reach, or at least we are prepared to integrate 100 gig KR2 and 200 KR2, and also 400 KR8, which is really in the recommendation. I don't know if it will be used one day in embedded system, but the recommendation is ready. One thing which missed perhaps in the first definition of the recommendation is the versatility of the Ethernet matrix. In 2010, you have, as I said, you have a set of 6 protocols, all giga, and only one in supporting 10 gig on 4 SerDes. And at this moment, Ethernet matrix support on SerDes 10 gig ports, and on other ports, on other SerDes, giga ports, but it was not possible to merge this. Today, it's possible. You can, for a profile like this one, each fat pipe can be by software independently configured, can be used as a fat pipe, but also can be configured in 4 ultra thin pipe or in 2 thin pipe. And for each type of pipes, you can select independently the protocol you want to use. That means that, for example, for an ultra-thin pipe, you can use giga, 10 giga, 25 giga, and later probably 50 gig. And on a fat pipe, this fat pipe can be configured either in 10 gig, 40 gig, 100 gig. So it's an explosion of the available configuration, which is no more possible to cover only with the simple module profile definitions. That's the reason why at the moment the new scheme for naming has been introduced, named AMPS, thanks, name AMPS, and which is a little bit difficult to read. Except for people who are always in the system, but in fact it's the only way today to be able to completely describe the capability of your product. One word on backplane optical interface. It has been presented already by other presentation before. If optical is available since a long time on the front, no, of course, it's possible on the rear also, thanks to the Vita 46, 67, and so on, aperture, and the corresponding backplane connectors for both the board and the backplane, which drive you can then have on such MTP, you can have 24 optical fiber. That means up to 12 ports, which, as exactly for copper, can be merged to create 40 or 100 gig ports. One word also on dual plan hybrid switch. The recommendation, of course, do not say anything about implementation of the board itself. We are driven as a switch manufacturer. We are driven by the profile, and in the present case, when you have an hybrid profile claiming for PCI Express for the data plane and Ethernet for the control plane, of course, you must implement both matrix on the board. When the plane are both Ethernet, you can decide to implement your solution based on a unique Ethernet matrix, or when required, because this solution based on a unique Ethernet matrix do not guarantee isolation between data flow. Of course, you can use Ethernet protocol, VLAN, you can implement access control rule to control the data packet received and decide to discard some of them depending on the rules that you imagine that you need to build your system. But this isolation is not what people are claiming for red and black architecture. And for this, we can also imagine a solution like this one on the left, where all the Ethernet matrix and the processing node are duplicated, one for the control plane and one for the data plane. I illustrate this on the SRIO platform. Of course, all the same features are available for 6U switches. All these products are available, were available since a long time for Giga Ethernet connection. Now all are available for 40 gig, 25 and 100 gig. I'm quite sure also that Giga Ethernet solution will be claimed and will be needed for a long time, exactly as the dinosaur RG45 connector is still there. But for sure, with all we have seen this morning, Ethernet switch with implementing full 100 gig link is the answer to the needs of today. Above this, we have a lot of features introduced supported by our software. It's a little bit too described, and it could be maybe the presentation of next year, and also we also heard this morning, and also the support for TSN for demanding application with strong deterministic needs.